Santolices. I'm Wilaine, Inso.
I'm Krystin Jaro.
And I'm Carlene Santolices. Welcome to our blog, and let's get on with the video.
As you can see, mathematics has a big role in our nature. But for now, let's focus on Fibonacci. Leonardo Pisano. Fibonacci was his nickname, which roughly means son of Bonacci. He introduces the sequence with a problem involving rabbits. As well as being famous for the Fibonacci sequence, he helped spread Hindu-Arabic numbers like our present numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 through Europe in places of Roman numerals. Rabbits. Leonardo Pisano introduces Fibonacci sequence of numbers using an idealized breeding population of rabbits. Each pair produces a pair every month, taking 1 month first to mature and giving the sequence 0, 1, 2, 3, 5, 8, 13, and so on. Each number in the sequence is the sum of the previous two. Fibonacci sequence prove that they reflect some naturally occurring patterns. You can commonly spot this by studying the manner in which various plants grow. We can easily find the numbers of the Fibonacci sequence in the spirals formed by individual flowers in the composite inflorescences of daisies, sunflowers, cauliflowers, and broccoli. It is also possible to find the Fibonacci sequence in nature is by the numbers of petals of flowers. Iris, 3 petals; Parisia, 5 petals; and Cosmea, 8 petals.
Next is the nature's numbers and shapes. Mathematical shapes can always be reduced to numbers, which is how the computer handles graphics. Each tiny dot in the picture is stored and manipulated as a pair of numbers, how far the dot is along the screen from right to left, and how far up it is from the bottom. These two numbers are called coordinates of the dot. A general shape is a collection of dots and can be represented as a list of pairs of numbers. Next, the main shapes that appealed to mathematicians were very simple ones: triangles, squares, circles, pentagons, spirals, spheres, and so on. All of these shapes can be found in nature, although some are far more common or more evident than others. There are also wave patterns on land. One example is transverse dunes. It is like an ocean waves line up in parallel straight rows at right angles to the prevailing wind direction. Sometimes the rows became wavy, in which case they are called Barkanoid ridges. Next example is the parabolic dunes, shaped like a U with a rounded end pointing in the direction of the wind. If the wind direction is variable, other forms become possible. For example, clusters of star-shaped dunes can form, each having several irregular arms radiating from a central peak.
Symmetry. Natural patterns include symmetries. It is when different sides are alike, like in honeycomb and butterflies, stripes like in zebra and tiger, spot is a small round color, different from the surface around it, like in Dalmatians and leopard, and many more natural patterns. Chaos. A kind of apparent randomness whose origins are entirely deterministic. For example, weather. Weather is chaotic because it is hard to predict and it suddenly changes. Next are fractals. Fractals are geometric shapes that repeat their structures on ever finer scales. For example, cauliflower. As you zoom in the cauliflower, you can see cauliflower but in smaller scales. Clouds are also fractals. Another definition of fractals are where a decomposed part of a figure is an exact replica or it's entirely self-similar.
So we'll be going deeper into the examples of fractal geometry. Here we have clouds. So the effect of fractal geometry is that you can determine that shape in terms of its size. So if you look at clouds from afar, you'll never know which one is bigger. This cloud that is bigger may appear smaller than the smaller one. So for example, if I am standing let's say southeast from a cloud, and for me that cloud looks bigger, but that one farther away could be kilometers bigger in diameter in terms of size. So here we have another example of a self-similar object. Let me just move this to the other side. Okay. If you see here, we have a picture of a coastline, and we actually have another one. We can both identify them, although they are from a different perspective. This is because they are self-similar or they have an indifference to perspective. You can recognize both of these as cosines because they have the same components no matter how far or how close you are. You have the sand, you have the debris, you have the water, and yeah, that's why they appear the same. And that is one of the effects of fractal geometry.
And that concludes our vlog. Don't forget to like,
Share, subscribe.
And hit the bell notification to notify you if ever we upload a new video. Bye!